All right. Let's say we're going backwards. Let's say somebody says, hey, I want to be this sure. I want to be 95% sure that this sample is close, certain, or that our approximation, our interval for a given sample is close enough as this margin of error, the actual result. How many people do I need to ask to be this sure? How many people do I need to ask for our interval to be this close? How many people do I have to ask for our margin of error to be small enough? Well, that's going to have to do with answering the question, what's our sample size have to be? Remember that our confidence interval, that's our sample proportion or sample statistic, plus or minus our z star, depending on what confidence level. Critical z-score will depend on the confidence interval, times the standard error, p hat q hat, over n, that poor standard error sad face. Well, the sample size, that's just n. How do we solve for n? Well, it's some algebra. You're going to subtract over that p hat, and you're going to divide by z star, etc. This is how you do it. If you solve for n, you get this formula. Margin of error, I called it mo earlier. These notes are calling it me. I like mo better, but you can write me or mo as you'd prefer. The textbook uses mo, M-O-E, so I drew a little tiny O between them. This is how we can find ideal sample size. So let's look at a problem. Make sure to always round up if n is a fraction. Because, for example, right, if we get that n has to be at least, 100.4, well, we can't ask 0.4 of a people, and we can't just round to 100. 100's not enough. We need to be at least 100.4. You're going to choose n equals 101. That's what we round up. We have to be at least n. Or n has to be at least this number that we find. So it's believed that 25% of adults over 50 never graduated high school. All right. And sometimes we do this. Sometimes instead of actually estimating with a sample, sometimes we'll estimate with like an assumption or an understanding or a belief. So a lot of times you will see something like this. This is going to be our p hat. All right. We wish to see if the same is true among another age group. So how many of this younger age group must we survey in order to estimate the proportion of non-graduates to within 6% with 90% confidence? Within a 6% margin of error. We want to be no more than 6% away. Maybe we're 6% above, maybe we're 6% below, but we want to be within 6%. All right. 90% confidence. Let's use this formula. N is going to be equal to p hat times q hat, 1 minus p, times z star, 90% confidence. What was that z star for 90% confidence? Well, you could go back to our standard normal curve and figure out what the z value has to be for 90% confidence. 90% confidence, that middle 90%, that's 5% on each side. Or you could just check earlier in your notes. For 90% confidence, z is 1.645. Divided by the margin of error, which we want to be 6%. Watch out. This needs to be as a decimal. 6%, whoa, what is that? 6%, right, is 0.06. Well, then all we have to do is type this into a calculator. Okay? So we have 0.25 times 0.75 times, I already forgot it, 1.645 divided by the margin of error squared, 140.94. We always round up. So we're going to have to ask, if we want to have a 6% margin of error, we're going to have to ask 141 people. And again, this is, again, another approximation. We haven't even asked the survey yet. We don't technically know p hat. We don't have a result of this survey. We're estimating p hat with our assumption. And that's done very frequently, and that's what we're going to do in some of these problems. Okay, so oftentimes p hat, maybe I'll make a little note of this. We often estimate p hat with an assumption or belief. And the reason for this is because there's a relationship between the confidence interval and this ideal sample size, right? The ideal sample size requires a p hat, but it doesn't make much sense to take a sample and then use that sample to figure out how many people we should have asked, right? Then you have to ask people twice. So that's why we use that belief or assumption to get an idea of our sample size. All right, it's an estimate, right? Statistics is all about estimates. That's very, very true, right? The whole idea of statistics is estimating the true population parameters. Very frequently, p and mu, the true proportions and the true means. Suppose we want to cut this margin of error to 4% with the same confidence level. How many people do we have to ask? Before we even answer this, are we going to have to ask more or fewer people? If we want a smaller margin of error, right? The margin of error is going to be 4% now. Do we think we're going to have to ask more or fewer people? Well, the more people we ask, I would hope the better estimate we get. The more people we ask, the smaller the margin of error should be. So if the margin of error goes down, we should have to ask more people. So again, n is going to be almost the same formula as before. Copying down almost the same thing. The only thing that's different is the margin of error. Now it's 4%. So just type that into a calculator again. Or if you already have it in Google, the only thing we're changing is a 6% to a 4%. 317.11. And again, it's really tempting to say, oh yeah, that's about 317 people. But n has to be at least this. All right, this is the minimum n. N is at least this. So we have to round up. So in order to get a 4% margin of error, again, it's 4 percentage points, which is a little different than 4%. In order to get a 4% margin of error, n has to be at least 318. At least 318 people, which is a lot more people. So for a 6% margin of error, only 141, but more than double that is required to get that margin of error down to 4%. All right. And that pretty much covers everything that we're going to do in this unit. I'll have in one more video just kind of talking about some homework problems and giving some explanations on why the answers are what they are to hopefully give some more context and more conceptual understanding of these problems. But as always, please also let me know if you have any questions.